Alright, so we have an Apple today. It's an Apple Pro something. Alpha 1466, I can't. 1466 maybe. Anyhow, the dude said it wouldn't power on. I paid 30 bucks for it. The dude said it wouldn't power on. So I've got it plugged in. It's drawing 62 milliamps of current. So I am not, that's probably not okay. Who knows? Suppose we'll figure it out as we go along. Or figure out what we don't know. Alright, where does power come in? It comes in over here. So let's, I was watching my mate Vince this morning and I noticed, I was looking at his mat and it's so clean. Everything's so clean. The only screws you see on his mat are the screws of the device he is disassembling at that very moment. And so I was like, you know, I should be more like my mate Vince, because old TJ just makes a huge friggin' mess. I just work on so many different things that I think I'm waiting on parts and that sort of stuff, you know. And so I don't want to like put it all back together and then take it all back apart. Okay, so that pin right there seems to be input voltage. Or no, was it this pin? It's this pin. So we have 20.2 volts coming into our system. And we have another pin here, 20.2 volts. So we definitely have voltage coming in. So, what does that mean? And we can definitely be sure it's not charging the battery. So I have to familiarize myself with all of this. So this must be the disk drive. That's a strange looking disk drive, man. So where else do we have volts? Do we have voltage to any of our coils? We have millivolts there. Millivolts there. This is probably the main power of this big old inductor, right? Nothing there. Did I already measure this one? Yeah. So where are we dropping? Where are we dropping our voltage at? So, all right. So let's unplug this thing for a second. How does this work? What is this deal here? Does this just unclip? It does just unclip. So how does voltage make it? Because this board does not look like it's maybe I should have watched a video on how to. So it looks like this little board right here is responsible for something. If I take this off, what is this? Would the voltage ride that thing over? Is that how that works? I don't know. So this must be for the fan here. What does this go to? What is this little deal here? I don't know. How does that come? Is there a clip on this thing? Where's my tweezers at? Is there a clip here? No? Oh, yeah. So what's plugged in there, man? I don't, oh, you know what? I wonder if this is the speaker cable. Let's see if we can disassemble the speaker, pull the speaker cable out. I don't know how to do this. Let me, let's look under the microscope, because Lord knows my old behind cannot see. Hey, it automatically switched over. Alright, so I think this just pops up then, looking at it more closely. So this would just pop up like that. And then that's out of the way. And then this looks like it goes underneath the battery. So that's probably for something up front. So this is most likely for speaker. This cable is most likely for fan. But then what is this big cable right here? Is that power? Ooh, you know what? Let's check that. Hold on. Let's start probing around. Ouch. Stab myself. Let's start probe. Oh, wait, hold up. The fan spun. The fan's spinning. Doesn't that mean it's on? Yeah, now my current's dropping up. Current's up to 432 amps. Or 432 milliamps. Isn't that? Doesn't that mean that it's on? Or at least charging the battery? I'm confused, man. Why is the fan spinning so bad? Bro, stop. Why was that fan spinning that fast? I'm assuming that an iPad takes a 20 volt input. I hope I'm not mistaken about that. Cause that one. All right, so let's figure out. Oh, maybe it does that if you disconnect that cable. Maybe that's like a. Let's plug the cable back in and see. Let's see if it does it again. All right, so we're back to. Fan's not spinning. Yeah, so we're back to the 65 milliamps. So when I plug that cable in, the symptoms change. Okay. Okay. So with this cable plugged in, and I don't have a. Unfortunately, I need a USB-C female to USB-C male so that I can move my ammeter. But yeah, what type of voltage do these things take, man? I don't know the answer to that question. Hopefully it's 19 volts like everything else. But you know it's Apple. No, it's not, dude. 14.85 volts. So I wonder if well, how do you, how does that work, man? So they work off of 14.85 volts. So that means that I've got this thing, right? That came with the console. So let's hook it up and let's see what the voltage coming out of this is. Well, I'll tell you, Apple cannot be just standard, can they? So let's disconnect this zip tie. Unzip this zip tie. Alright, so let's plug this thing in and let's see if we get voltage on those pins. Yeah, so we're getting 16 volts. So, are we getting anything on the battery? Let's, nothing there. Nothing there. Nothing there. 110 millivolts. It's like something wants to be there. So that's 0.6 volts. Oh my goodness. Dude. Why does it like flash up to 2 volts and then back down to 0.6? That's weird, man. So yeah, so it's definitely not 20 volts. So let's unplug this. Let's disconnect this cable again. And then let's see if the fan spins like it did before. Yep. The fan spins just like it did before. I can't tell how much current's being drawn, but I'm fairly certain it's not going to work. So voltage, is voltage carried over by that bottom cable or the top cable? Which one? Let's probe around. You know what I'm going to do, bros and broettes, is I'm going to put on my I can see better glasses. Uh-oh, there goes the fan again. Joker's out of control. Bruh, stop. Dude. Yeah, 16 volts. Okay, so yeah, so voltage is making it to the board. So then what does this freaking cable right here do? What does that cable right there do? I'm not sure. So we know 16 volts is coming along and it's coming into the board. And yeah, now that I think about it, that makes sense because the fan starts to spin. So how would the fan spin if it didn't get voltage over here? Or maybe you have to have a M2 drive in this thing for it to... No, it should boot up without that. So this must be for my LCD. Okay, so let's go back under the microscope and let's see if see what we see. All right, so what's that there? I thought it might be liquid damage, but maybe not. Maybe it's just it's just dust or something. Well, let's probe for some shorts, man. Set our multimeter to continuity mode. Okay, that's definitely shorted. Well, that's definitely shorted. That's definitely shorted. What on earth, man? Okay, that's shorted. So that's not good. So, I mean, if I inject a volt in there. All right, let's quit being lazy and let's remove the board. I'm gonna learn how to do it. I may or may not record myself doing this. I'm not sure yet. All right, we have a short somewhere. So let us figure out, let's find ground. So there's a short on that big, no, one side is not shorted. Okay, so it's not shorted. Okay, that's good. What about this? That's not shorted. That's not shorted. And that's not shorted. So are these the two input MOSFETs here? I'm assuming an Apple's like any other laptop. It has two input MOSFETs for protection. There's a lot of components on this bad boy, man. I suppose it would be best to go under the microscope and analyze this thing. So let's switch over and see if we can give a visual inspection. Alright, first thing we see is some corrosion. I'm assuming I think that's corrosion. Could be wrong. Alright, so there's corrosion there. There's corrosion there, so we'll remember that. So let's scan across. Looked at one point there was corrosion here. So the seller of this thing said that he bought it to repair it, but he didn't have time to look at it. So he basically said, my loss is your gain. But it's also equally possible that he did look at it and it was corroded and he couldn't figure out what was wrong, and so he sold it for $30, which, I mean, I don't really care. This is my first time trying to work on a MacBook, so it'll be interesting to learn on. See if we can at least narrow down what the fault is. Alright, so the only place we saw corrosion is right in here. So let's take and measure continuity from ground on those 2 points and on those 2 caps and see if we got any shorts here in this area. Is that not ground? Where's ground? Is this ground? Yeah, that's ground. Okay, so nothing. Short on that side. I'm saying open load. Let's clean those up. Just to, I don't see anything obvious. I don't know what this little deal here is, man. What's that? What side of the board is this? Must be the, yeah, it's the side away from the power. Hey, look at that. You can't even tell there was ever corrosion there. Bro, I am a daggone cleaning expert. But if it looks to me, honestly, if I'm being honest, it looks like those 2 capacitors there they're not sitting on there properly. It's almost like somebody replaced them. So we got a short there, right? On this side, it's an open. It's wide open. And I don't think it should be open. Switch to diode, man. And usually, alright, red probe on ground, black probe. So we get 0.5 volts there. We get nothing there. Nothing there, or short there. So, yeah. Let me do some research. Maybe I can find a schematic. I don't think I'm going to be able to fix this by visual. Well, I mean, I suppose I cleaned that corrosion. Maybe that fixed it. Who knows? But yeah, we'll see. All right, I've been doing a little learning, and so I still don't know what this is. No idea what that is, man. It's a jumper to jump something. But when I disconnect it and plug it in, the fan starts spinning like 1,000,000 miles an hour. Anyhow, so when I plug this in, I'm supposed to have an LED, whatever color that is. I'm not sure. I don't own a Mac. I'm not a Mac dude, you know what I'm saying? So I don't know what indications should be or should not be. But anyway, so I watched a video by Mr. Louis Rosman, and he said that the very first thing that you need in order for this laptop to work is PPV something 4 hot. PP3V4 G3 hot or something like that. Anyhow, so I went and I found a schematic. So we're gonna take a gander at said schematic real quick to show you what I am thinking of, or what I'm looking at. So we're gonna go to, so if we control zoom, you know, let me make sure my voice is being captured. Yep, it's being captured. Okay, so if we if we analyze this, where how you do a hand, there we go. All right, so this is our power connector coming in, right? So I'm going based solely on the fact that he said you needed that PP3V4G3 hot, or whatever it's called, PP3V4 G3 hot. So anyhow, if you don't have that, I guess you won't have a green LED. So coming through here, this is our DC in, our 16 volts DC in. It comes to a MOSFET Q7010, and the output of this MOSFET is the drain. So we have 16 volts on one side. If the MOSFET is on, we should have 16 volts felt here, and then we should have, and then it's going to go through this resistor, and so somewhere along the line we come down to U7090, and the voltage in is obviously what it says here, 18.5. I don't know how it's going to be 18.5 when you got a 16 volt charger, but anyhow, voltage in is 18.5 volts, and then on the output we should have our PP3V42 G3 hot, and then through this inductor, and then here, right? So that's what we should have. So let's switch back over to the camera, and let's take and see, based on voltage, we know that if we come here and we go to one of these pins, we're getting 16.7 volts. So if you figure it out, this chip right here is those two MOSFETs. I can't remember what they're called, but let me put on my I can see better glasses. You know what we're going to do? We're just going to switch over to the microscope, y'all. That's what we're going to do. All right, so where are we at here? So this chip right here is the two MOSFETs we looked at in the schematic. So pin 5, which I'm assuming, I guess this would be pin 5. Pin 5 was the output of this MOSFET. And so as you notice, we're getting 16 volts on the output of that MOSFET. So then when we go down here, this is that other chip, the U7090 or whatever, right? And I'm guessing this line is pin 1. And which pin did it say was supposed to be the input? Pin 6 was the input. So let's find pin, am I looking at the right chip? Yeah. So 1, 2, 3, 4, 5, 6. So pin 6, and we're getting 15.87 volts. So we know we're getting voltage into the chip. And then what was the output of this chip? The output of this chip was our G3 hot on pin 4, and it should be 3.42 volts. So if we come to pin 4, which is this pin right here, we're getting, it's bouncing around. So that's not good. And then obviously it goes to this inductor. So we should have voltage on that inductor. And we do not. So we know we've measured input. We've measured the input to the chip. Well, first we cut the circuit in half and check the output of the MOSFET, right? To help let us know whether the problem was back or whether the problem was on this side. So yeah, so I think, you know, in a normal troubleshooting scenario, if we say, well, the voltage, we have good voltage in and we have bad voltage out, that means that chip is faulty. And that chip may very well be faulty, I don't know. But the other step we have to do in this process, because of these ceramic capacitors, is we have to measure resistance on the output to make sure that something's not shorted. So if I check on this inductor, which is the output of this chip, notice it's shorted. So, and it's shorted, and that's obviously an inductor as well. So it's short. So the question then becomes, well, what's shorted, right? So I figure, you know, being the super techs that we are, we should go ahead and figure out how to ground said device. I don't know what's a good ground. I guess so. I'm gonna take my power supply, and I am going to set it to 1 volt. Right? I'm gonna set the current to 500 milliamps, and then we're just gonna splash some alcohol down in this area and see if it bubbles away. So when I connect power, or when I inject voltage. So I don't know how I'm gonna do this. You know what I'll do? So I'm just going to use, black probe's going to go on ground, and red probe's going to go on that inductor, and we're going to see, let's splash some alcohol in that area, and let's see what gets hot. So let's see if anything gets hot in that area. Let's cut our power supply output on. 1 volt, 500 milliamps. I don't see anything getting hot, bro. It's definitely shorted. So that means I'm going to have to use the thermal cam to figure out where this short's at. I was hoping it'd be right in there. Well, of course, that glue might be. You know what? Let's dig up all this glue. How do you get this glue off of here? Do I gotta heat that up? I bet I do. Let's remove our antenna cables. Or as they say in the South, our antenna cables. Probably, you know what, let's remove this. Let's switch back over to the main camera. All right, so let's remove this. Let's remove our Wi-Fi module. Ooh, what if our Wi-Fi module was shorted, bro? You know? Does this just unplug? There we go. Oh, all right. Let's see if we still got a short. Let's check that real quick just to make sure. Well, no. I guess that didn't help matters much, y'all. Yeah, so it's still shorted. So let's all right, something's getting hot right in here, so it must be on the other side of the board then. All right, let me take it out and flip it over, and we'll be back. I cannot figure it out. It's something in here getting hot. It is something in here getting hot, or at least that's what the thermal cam shows. I don't know, man. I don't know. So every time I do this, something is getting hot. I mean, like right where I'm probing with the probe. So I think I'm just gonna snatch off a couple of these components and see if I can't figure out which one is causing the issue. So while I was trying to figure this out, I just decided I couldn't figure out exactly what was going on. So I said, you know what, I'm going to remove some components and see if I can figure out
why this short is not showing up as heat. And I have that problem often. I don't, maybe I'm not injecting voltage correctly or whatever, but in this case I was doing it properly. I just couldn't find the short. So this entire time I spent just removing these components, and the short's still not going away. And so I probably troubleshot this for 3 days off and on, trying to figure this out. So I'm not going to bore you with the hours and hours of video footage I have of me trying to figure this out. I'll just skip to where I start to understand what's going on. And it still took me another 3 days after this to figure it out. So we'll pick up there.
All right, so check this out, D. So if, like it is right now, if I come in and I measure resistance, notice I do not have a short, right? If I were to power this up, or if I were to plug in the cable, if I come check voltage, I'm getting 3.4 volts DC. Yeah. So that's normal. In a working one, I guess that would be normal. But as soon as I plug in this cable right here, watch what happens. Now if I go back to resistance, if I measure resistance, notice it's 0 ohms. So this cable is shorting out my PP whatever. That's just crazy. I don't get it, man.
Alright, so let me tell y'all where I'm at with this thing. I've been working on this thing for a while, and when I left off, my multimeter thing ain't working. Hold up. Why aren't you working, bro? Failed to open COM port 3, huh? Oh, did I unplug this? I did. I did unplug it. That's the issue, bro. Alright, let's try this now. Alright, we're in business. Alright, so I've been working on this thing for a long time, man. And I want y'all to keep in mind, I've never touched an Apple, MacBook, or any other type of Apple computer. I suppose if you grew up on them, you know, it's intuitive to use. I've not ever had a desire to try to relearn that specific operating system. But so I bought this just because it was $30, and I said, you know what, let's try to fix it, right? So when I got it, the problem we were having is if my green light doesn't come on when I plug in my Apple charger, and I figured out that we have a short on our 3.4 volt rail, right? And the 3.4 volts is necessary to begin for the computer to boot. It won't boot without that 3.42 volts, right? So I removed all these components. If you remember, I removed the capacitors. I've injected voltage. I cannot find where that short is coming from. I cannot find it. I traced it to the connector. I was like, man, this connector has got to be bad, man. So I desoldered the connector. I resoldered the connector. I've inspected that connector, and I cannot find anything wrong with that connector. And I know that 3.4 volts is felt over here somewhere, but it didn't matter if I had only this end plugged in, and this other end, I could not have the I/O board connected at all. And it didn't matter. I got a short. As soon as I plugged this cable in, I'd get a short on my 3.4 volts. Well, when I got this laptop, this cable was plugged in like this. That's how it was plugged in. That's exactly how it was plugged in. So, me having never taken one apart, it didn't dawn on me that perhaps that's the the wrong way to plug in that cable. And in a last-ditch effort, because I was about to give up on this thing, on a last-ditch effort, I said, you know what? Let's reverse this cable. Let's plug it in this way and see what happens. So let's do that real quick here. So now with that cable plugged in, remember previously it was short. All right, so let's check and see if we've got a short on our 3.4 volt rail. Notice we do not have a short on our 3.4 volt rail. So let's apply power and see what happens. Notice our light illuminates green, fan starts spinning, and the laptop will most likely turn on, right? And I know you guys might be watching saying, well, geez, bro, why didn't you think to do that before? So the laptop boots just fine. The problem I'm having, real quick, I'll finish my other thought. I'm bad about starting a sentence and then changing the sentence. And when you're trying to edit a video, it's terrible. So notice I don't have any backlight. So that's my issue now. I don't have backlight. So it took me this long to get to the other problem. So yeah. So as I was looking at it, every time I would plug in that cable, I'd be like, man, that's a stupid way that Apple decided to route that cable. It's right across the fan, bro. You're gonna impede airflow. And it never dawned on me. I kept thinking it, but it never dawned on me that perhaps the person that sold it to me, they were having the same issue and they couldn't figure it out. And that's how they had the cable plugged in. So the problem I'm having now is the backlight. So I know you guys, this was tricky for me. I don't know why it never dawned on me to flip the cable, but it didn't dawn on me to flip the cable until I was about to give up. Just because, I was worried something might break or whatever, But, so yeah, so if we go now, obviously since we're getting the green, well, I don't have the battery connected, so we're getting an orange light, but if I check for voltage on that 3.4 volt rail, you'll notice we're getting our 3.4 volts, right? So what are we missing? Now, the backlight doesn't work, so the backlight obviously comes in on our port over here, and we should have 20 something volts at this inductor right here. This is, the backlight inductor, and we don't get 24 volts. Now at the backlight fuse, which is here, this little fuse right here, we're getting 8.6 volts. So it's going into this chip, but coming out of this chip, which is, I think, this pin right here, we get nothing. We get nothing coming out. And and I can't really see, and I don't want to short something else. Let me put on my I can see better glasses here. So right here we get 2.8 volts. So we know that we have 8 volts coming in. 2 volts is coming in on the gate, and this is a MOSFET right here. And that 2.4 volts originates, if I can get closer, it originates at this chip right here. That chip turns on and it allows current to flow from drain to source on 2 MOSFETs. That chip has 2 MOSFETs inside. And that 2.7 volts or whatever it was is being felt on pin 3 because this MOSFET is on. If that MOSFET were on, you wouldn't receive any voltage there because there would be no path for current to flow. And if I could find the schematic, I'll try to show it to you. So yeah, so we have good voltage going into this chip, and we have bad voltage, and we don't have any voltage on the output of this chip, 160 millivolts. So let's disconnect power. Next question I have is the actually, let's do this. Let's check for voltage one more place. So we have we'll check for voltage on this inductor. We'll wait for the computer to boot. Alright, computer's on. So we should have what? Well, we have 8 volts there. So that 8 volts is coming from that chip right there. We have 8 volts on this side of this inductor. So that means we should have 8 volts on this side of the inductor. And we have nothing on the other side of the inductor. And then that feeds that diode. And these two capacitors, these big old honking capacitors right here, let me go under the microscope to show you this so you can see it a little bit more clearly. Maybe this is better. So this is that chip I was talking about. We have 8 volts felt into through this fuse right here into pin, that's pin 4, right? Because here's pin 1 right here where the dots at. So 1, 2, 3. So pin 3 is the ground potential that's being felt through these two MOSFETs in this chip right here, through this resistor, and this resistor is what's producing the voltage drop, the 2.7 volts on the gate of this MOSFET right here. The drain, I think it is, or maybe it's the source. Dude, I've really got to learn MOSFETs. I understand silicon, or PNP, BJT. I understand BJT pretty well, but I don't understand MOSFETs very well. So our input voltage is felt on pin 4. Our gate is biased by this 2.7 volts. So this MOSFET should be on, and the output should be felt on pins 1, 2, 5, and 6. Yeah, our output should be felt there. And like I said, we are feeling an output. No, that's the wrong thing. That's ground. So we're feeling 8 volts here on the input to this MOSFET. No, we're not feeling it. Oh, I don't have it. Lord have mercy, the other probe wasn't grounded. So if I come to the input of this MOSFET, I get 8 volts. But on the other side, or not MOSFET, the inductor, on the other side of that inductor, it's a short to DC, right? So I should feel 8 volts, and I do not. So let's now check. Let's disconnect power, and we'll check to determine if this is shorted. So we'll go to resistance, and we'll check to see if the output, and we know it can't be shorted because the input, if it were shorted, then this side of the MOSFET would be shorted also, and the output of this chip would be shorted as well. So we know it's not shorted, but that still doesn't explain why we have voltage on one side and we don't have voltage on the other. So let's ohm this inductor. Let's ohm this inductor. We should have 0 ohms on this inductor. Would you agree with that if you're watching? And notice it's open. It is open. So could it be honestly as simple as an open inductor? I can't imagine an inductor would be open, but that's what it seems to me, that inductor is in fact open. So let's take the board out. So I'm going to take this board out, and then we'll measure again. So I'm going to take this board out, and then we'll measure again. So, all right, I'm going to try to get this thing off without using hot air. I think I'm going to put a little flux down. I got to tell you, that was pretty easy. Let's ohm this inductor and see if it's open. Can't imagine it is. Dude, it's open. That is weird, man. That inductor is open. Let me check it again, man. How on earth does an inductor get open? Let's check one more time. Bro, it's open. That is nuts, man. Well, let me I'm gonna go find a motherboard or a laptop motherboard, and I'm just gonna pull an inductor off of the backlight circuit and see if I can find one that kind of matches. I don't know what those, suppose I can figure out what those numbers indicate. I'm sure they tell you what Henry voltage rating and all that kind of stuff they are. But all right, let me do some research and try to find an inductor to put there, and then I'll be back. All right, so I have been looking for a inductor. This is the closest thing I found. It looked like it was on the backlight assembly of another laptop, but when I was sitting here, when I was cleaning off the pads, I figured out something. So it's not that this inductor is open, it's that the inductor is broken right in here. It was snapped. So I need to figure out a way to, I'm going to solder this back on there. The side that has, so we're going to solder this side to this side over here. So I think what I'm going to try to do is I'm going to try and solder directly to that. Let's flood it with solder. Alright. So then what we'll do is we will try to hold this thing in place like that. And then we'll come in here with this. Okay, so I think that should be okay. Let's try to get this thing on here. Do we have a short from the diode? We do. Do we have a short to the other side? We do. Okay. I think that is fixed. That was pretty difficult to do, man, because there wasn't a lot of surface space. Oh wait, it's on. It's on. Holy cow. Okay, let me unplug it. Okay, so now the next step is I don't know how to install software on this thing, man. So that's gonna be the next step. So I have no idea how to do that. All right, here it is in all its glory. It's all put back together. I found some screws from my collection of laptop screws. I bought a 128 gig hard drive. I installed it, and the only flaw with this thing really is just a little scratch on the screen. You probably can't see it, but yeah, I put it in. I installed Mac OS by holding down the Option key and pressing power, and then I connect it to the Wi-Fi, and yeah, here we go, man. Battery holds a charge. It charges properly. Yeah, all in all, it's not a bad laptop. I don't know if anybody buys Apple laptops this old, but I don't know. It's pretty nice. I don't have any use for it really. I don't know what I would do with it, but it's just going to sit around and collect dust, you know. But anyways, so yeah, first MacBook attempted repair, first MacBook successfully fixed. I am pretty daggone proud of myself. So I got another one I got to look at as well. I got some more laptops. I got the PS4, the Sega. Oh, I got all kind of stuff, man. It's starting to collect up. My wife's getting mad, so I got to get busy putting out some videos. So, all right, man. Y'all be good.